All right, so this is going to be the last one. It's a little bit long, but and probably some of the harder stuff that we're going to do. So take good notes, and because you can always use these on the test. Okay. All right, so take a look. It just says triangles and parallel lines. So one of the theorems says, and by the way, on all of these problems, when you get them, if you look at the explanation, you can always find the official writing of the theorem and you can copy it down. But basically, if you cut a triangle by a parallel line, check it out. You basically are creating two similar triangles. Why? Because we know that they share this angle, so they have this one, and they also, this is a transversal, and these are two parallel lines. And these are corresponding angles. So we have two angles, right? And if we have two angles that are the same, we know that the last one is the same as well. Okay, let me go ahead and erase that real quick. My recommendation for everyone here is to copy this down and copy them separately. It will help you keep your sides straight. It really will. If we were in class, and if we are in class, and you were asked to ask me for help on this, I would make sure that you had written it like this first. I wouldn't help you until I had seen that you copy it down, two separate triangles with all of the measurements listed. Okay, so this is TUV, that's the little one. This is TRS, and these are similar. Okay, given that TR is 14 and TU is 8, RS is 49. Find UV. Okay, I'll call it X. So basically, you're just setting up a proportion, and that's it. The main thing, I guess the difficult thing in this problem is seeing the two triangles and seeing how they relate, okay, how they are similar. So I don't feel like I need to do this problem because you've probably done a million of these, and I don't think you need to either as far as for taking notes. I'll set up the proportion though. So the proportion could be like X over 49. If you notice, I always try to put X on the top just because it's my own favorite place to put it. So I'm going to go X over 49 is equal to 8 over 14. Get it? I did small, large, small, large. I could have also done X over 8, which is small, small, equals, and then 49 over 14. I should say small, smaller, small, smaller. Okay, you get the idea? Okay, but this is the small triangle. This is the large. So you have many options for setting up the proportion, and then you just cross multiply and solve. I'll make these notes faster by not solving all of these because that isn't the lesson for today. It's basically just how to set them up. So here's the second problem. Pause it if you want to, or pause it if it takes you longer than it takes me to draw these triangles. Okay, so we've got T, U. No, we don't. No, we don't. That's the little guy. The little guy is W, X, V, and this is T, U, V. All right, so we have similar triangles because these two lines are parallel, because they told us they were parallel. If these are parallel, then we know we have similar triangles. Given that VW is equal to 20, VU is equal to 49. VX is equal to 28. Find VT. All right, so make sure that the orientation, they purposely gave it to you out of order, but as long as you have them drawn in the same orientation, it's really easy to see which sides correspond, okay? So I'm going to set it up. I'll call this X because I like X. X over 20. X over 20 is equal to 49 over 28. And I am going to pause this for a second because I'm getting an important phone call. All right. All right, you guys. So you would cross multiply and solve. Okay. All right, next one. So these ones, here's the theorem. The theorem on this one is that when, actually, and I want you to go ahead and copy it down. I don't think I have an ability to write a text box here, do I? That's a sticky note. That's a select button. See, I don't think I can because I did actually just cut. Oh, here it is, right there. Ah, let's see if I can manipulate this thing. This is funny. Okay, let's try this, you guys. Wow. Wow. Let's see. Okay. Well, that didn't work. I don't really know what to do. Okay. Idea is there, but okay. Here it is. I'll do it like a news thread here. It's called the triangle angle bisector theorem. So in a triangle, an angle bisector separates the side opposite the bisected angle into two segments whose lengths are proportional to the lengths of the other two sides. What does that mean? What it means is this. It means that when you cut, see how this is an angle bisector? So we took a triangle and from one of the vertexes did this, okay? It means that this is proportional, okay, to this piece, and this piece is proportional to this piece, okay? Actually, you know what I'll do? I'll do it in a different color. And this piece is proportional to this piece, all right? So I could set this up for this one, knowing this, okay? I could set it up as 3 over 9 is equal to 4 over x and cross multiply and solve. Or I could go x over 9 is equal to 4 over 3. It's actually really easy to color code these. This is actually one of the harder ones in my opinion. It's not obvious. It's not something that you perceive. And they're also going to give you some that you have to problem solve a little bit here. So to me, these are the hardest ones. And so if you do have color coding available to you, I would recommend doing that. So let's take a look at this one. So here's my angle bisector right here, okay? That's going to divide these two pieces that are proportional, okay? And these two pieces that are proportional, all right? So if you have available to you some kind of colors, that kind of helps sometimes. Now here, check this out, you guys. This is actually a little tricky. Take a look. We have the length of this triangle. It's 6 and it's 4. And this is 9, but this whole distance is y. But we don't want the whole distance. We want this little distance. So my little trick to do this, if you don't understand immediately what this answer is going to be, let's pretend. This is my way of understanding the problem. Pretend. Just name any value for y. It doesn't matter. Let's pick 10 because 10 is easy. That's not the value, you guys. Don't think it's the value. I'm just making this stuff up. Okay, this is pretend. Pretend. Pretend y is 10, right? Let's pretend the whole distance is 10, and we know this is 4. What would this be? It would be 6, right? Because 10 minus 4 is 6, right? Well, that helps us understand that what we have to do is take the whole distance and subtract the little distance. So this distance right here is y minus 4. See, you take the whole distance y and we subtract the 4. Me saying 10 just helps me under. Oh, wait. Come on, honey, come back to me. Okay, there we go. Sorry about that. I need to do this. I need to lock this down. Okay, now I can't. So anyway, I'm pretending. We're done with the pretend. Okay, there you go. So now this is different. I am going to go ahead and do this whole problem because I think some of you guys will be wondering about how to do it. So I'm going to put the blue over the blue and the yellow over the yellow. So I'm going to go y minus 4 over 4 is equal to, so I did this side over this side, so now I need to do this side, 9 over 6. Remember, you have to put the sames, okay? Cross multiply, so you get 6 times y minus 4 equals 36. Now distribute. So now you're just doing your algebra 1 problem. Okay, add 24 to both sides. And you get 6y equals 60. So y is equal to 10 because 6 times 10 is 60. All right, is that what they asked you? Yes, it did. They said find the value of the variable. So yeah, there you go. Okay. And that one I didn't do. All right, let's take a look at another one. You might want to pause it if you want to do it on your own. Okay. Again, I'm going to color code it. Okay. I'm going to take purple and I'm going to mark purple goes with purple. Okay. And green goes with whatever this is. Okay. And what is that going to be? Okay. So we're going to take the whole distance. We're going to subtract the part we don't want. We only want this distance. So we got to take the whole distance and subtract that. So this is going to be x minus 2. All right. So now we put those in a proportion. 2 over x minus 2. So I did this one over that one is equal to 3 over 6. And then you would cross multiply and solve. I don't need to do it because I did it before. And I think you guys are good. Well, I don't know. Maybe I do need to do one more. I'll just do it really quick, okay? I suggest if you are struggling with this that you pause and make sure you know how to do it. And check your steps, okay? X is equal to 6. And then here, this is, again, all you had to do. Okay, this is with this. Oh my God, that almost threw me for a loop there for a sec, you guys. Okay, and this with this. So you can also do black over red, as long as you know what you're doing. Like I could have done black 9 over red 6, because they're on the same triangle, is equal to black y over red 8. That works too, okay? That's going to be the same thing as if I did 6 over 8 is equal to 6 over 8, 9 over y. You see, 6y equals 72, 6y equals 72. Same thing. All right, moving on. Okay, let's take a look at this one. Okay, what they're doing now is making sure you understand how to name triangles that are similar. So what they're going to do is they're going to give you triangles that are not in the same orientation purposely just to mess with your head. Okay, so take a look. Here you've got triangle ABC. So you've got to figure out which sides are corresponding. So look, obviously the large side is large side. You could, oftentimes you can identify them as large, medium, and small. Sometimes you have to, it's a little bit harder if they're pretty close, but 16 goes to 8, right? 10 goes to 5, and 8 goes to 4, right? Because 16 divided by 2 is 8, 10 divided by 2 is 5, 8 divided by 2 is 4. So do you see how they're in opposite orientations? 4 is over here on the right-hand side, and 8 is on the left-hand side. They did that intentionally just to mess you up. So you have a choice. If you can flip it in your brain, that's fine. If not, you can rewrite it. Like you could put 4 here, 5 here, 8 here. And then, okay, look, 4 and 8. What's the vertex between 4 and 8? It's E. So that's this one, E. And then D is going to be the one between 4 and 5. That's D. And then the one between 5 and 8 is F. So when we say A, B, C is the same as E, D, F. E, D, F. By the all sides are proportional. That's probably what you're going to pick. Like all three sides are proportional. If all three sides are proportional, then the triangles are similar. Okay, that's going to be the theorem. All right. Then look here. You got a mark here. That's an angle. That's an angle. These are vertical angles. So we got 2 angles. Therefore, the third angle is also equal. If 2 angles are the same, so is the third. Okay. So note that like which angle it is. This is blue to red to black. Wait, what did they do? They did X, Y, Z. So they did red to black to blue. So we want to do the same thing here. Red, which is M, to black, which is Y, to blue, which is N. MYN, triangle MYN, by the angle theorem. If all the angles are the same, then we have similar triangles. Not congruent, guys, similar. Similar, similar, similar. All right, let's look at another one. I'll try to see if I can enlarge it a little bit again. It definitely is a little small. Come here, move it this way. All right, there we go. All right, so take a look. Check your sides, okay? So I'm going to assume, well, I shouldn't assume anything. Never mind. This would be the longest side. So 6 to 15. Okay, so I would go 6 is going to 15. Is that equal to, let's compare another couple sides. The smallest side to the smallest side, you guys remember? So this is, look, small, medium, large, small, small, medium, large. You always want to compare the right sides to the right sides. So I'm going to go medium, which is 5 over 12. And is that equal to small, which is 4 over 10? So let's reduce these. 3 goes into 6 and 15. It goes into 6 twice. It goes into 15, 5. 5 and 12 are not divisible by anything. So do you see how that's not equal? And this would be 2/5. So these two are, but this one isn't. And that always makes me double check. And yes, I didn't do it right. Yes, I did do it right. That's the medium. Yes, that's the medium. That's the medium. So I did do it right. So these are not similar. Not similar. Okay, so you don't have to pick one of these because they're not similar. Check these. Okay. They give you the small angle and they give you the fact that it's a right. So we know that this is 90. So we can figure out the third angle. These two angles always add up to 90 because that's 90, 180 minus 90 is 90, right? So these two add up to 90, and this is going to be 55 degrees because 5 plus 5 is 10, carry the 1, and you've got 90. Okay, that means, look, they're the same. And if we figure out the third angle here, it's going to be 35. So yes, they are similar by the angle theorem. All right, take a look here. You've got one angle, but you have nothing else to go by. They didn't give you any other angle. So we don't know if they're similar or not. Not necessarily similar because we don't have enough information. You have to have either all sides are proportional, not 2, but all sides are proportional, or all angles are the same. Okay, next. Okay, now you're going to talk about scale models, and this is how you use proportions. Proportions, whoa. What did I just do? I don't know if you guys saw that. That was fantastic. Okay, here we go. Let's see. Let's get bigger. I was trying to make it bigger. Here we go. Okay, so this is really practical if you ever want to make a scale model of anything. Okay, you basically are making, and this is how they do it in the movies, by the way. And they figured out, I believe, that the scale models in movies are 1/30th of the size or 1/40th. Can't remember, but they literally have a scale that they always use. And like they build, like if they want to blow up the White House, they build a scale model of the White House. Okay. In this case, we have 1 inch to 9 feet. Notice the units, they're not the same. And that's going to help us set up our proportion. So we have 1 to 9. Notice this is the inches, and we're comparing them to feet. So when we set up our proportion, we want to make sure we put inches there, feet there. Okay. It says in the scale model, the length of the boat is 10 inches. What is the length of the real boat? Now, you guys might be able to just do this in your head. Like some of you will just be able to go like, well, of course, it's just, like if it's 10 inches, then it's 90 feet. But some of you guys might need to set up a proportion. So to set up a proportion, you use the scale, the given scale that's always included right here. And then you make sure you put the correct part. We are looking for the length of the real boat. That's going to be feet. Okay. And then it says 10 inches. So the 10 is going to go on the top. And then the question mark is here. So let's put X. Cross multiply, and you get X is equal to 90. Now I'm showing you with a proportion because that makes it easier to solve. But if you can do it in your head, you're fine just doing it in your head. I'm not going to stop you from thinking. Okay. The height of the real boat is 63 feet. What is the height of the boat in the scale model? So notice they gave us feet. So we're going to still use the scale, but now we're going to plug in the bottom and put the x on the top. So we're going to get 9x equals 63. So x is equal to 7 what? Inches. Because we are going to we were on the top with inches and we were talking about the model. So be careful about units. Sometimes Alex gives you the units and sometimes it doesn't. All right, so here's my other scale. I'm talking in a scale model of a television. It goes in a scale model of a television, 1 centimeter represents 4 inches. Okay, the length of the real television is 36 inches. What is the length of the television in the scale model? Again, if you can just do this in your head, you're welcome to. But this is how you do it with the math. 1 centimeter for every 4 inches. Now, you don't need to put the centimeters and the inches when you do the math, because that's confusing sometimes because it looks like variables. So I'll put cm and inches over here. Okay, just to remind myself that that's what's happening. Okay, 1/4, and then look, they gave us inches. So we're looking for model. Okay, so 36 inches. We're looking for x here. Okay, cross multiply, solve. Done. Okay. Next, in the scale model, the height of the television is 7 centimeters. That goes on the top. What is the height of the real television? So x is equal to 28. There you go. Okay, so it's not really hard, especially if you set up a proportion. It takes some of the thinking out of it. Okay. All right, here we go. Same units now. Scale factor. Here we go. The table below gives dimensions of a painting and a scale drawing of the painting. Find the scale factor of the drawing to the real painting. Write your answer as a fraction in simplest form. All right, this is important. Words are important here. When they say scale factor of the drawing to the real painting, okay, they're asking, okay, you guys, this is one that I literally have to force myself to think this because it's opposite of the way that you would think. Okay, I always think the scale factor is what you multiply it by to go from drawing to real painting, but it's actually vice versa. When the words say drawing to real painting, we're looking at what you would multiply the real painting to get to the drawing. Look, well, on this one, you can look in the explanation to make sure. The method is the same. All you do is you go drawing to real painting. Okay. Okay. I'm sorry. I realize this now that I say this. Drawing, painting. Okay. So, or painting, drawing. I feel like it goes like this: painting, drawing. Even though the words said drawing, painting, drawing to the painting, I think we find it this way. It's counterintuitive to me. So sometimes, and there are a few things that to me don't always make sense. 5 to 3. Okay, so it would be 5/3. If I did it this way, it would be 9 to 15, and it would be 3 to 5 or 3/5. So in other words, and we could do it with the 10 and the 6 as well, you guys. I think they're giving it, this should be the same. 10, ooh, 10 to 6 for the width. Okay, this is the length, this is the width. That reduces to 5. No, it's the same. I was like, it should be the same. That's too weird. They give us something weird? No, it's 5 to 3. Okay, so let's talk about direction. So you see how one is 5/3 and one is 3/5. One is 5/3, one is 3/5. All right. So obviously the painting is bigger than the drawing. So here's the painting, right? And then the drawing is smaller. Okay, this is the drawing. This is the painting. Okay, what it's saying is that the drawing is 3/5 of the painting. In other words, it's smaller. Do you see how 3/5 is less than 1? That means it's smaller. 5/3 is greater than 1. So to get from the painting to the drawing, okay, we would have to multiply 15 by 3/5. So I believe this is the answer. Okay, but again, I told you, like, honestly, I should double check me when you do these. Okay, you'll have the fraction either way, which way, and then make a note of it so you guys can tell me. I'd be really happy if somebody would tell me. Okay, the scale factor, though, is simply by comparing them. Like 63 to 9 is painting to drawing. Okay, which, okay, I think I know why. Because look, 7 to 1. The painting is 7 times bigger than the drawing. Do you see that? 35 to 5, 7 to 1. All right. So to get from, okay, to get from the painting to the drawing, we would have to multiply by 1/7. So it's kind of backwards than what we would think. See, it's not 7 to 1, it's 1/7. And here it says to find the scale factor of the drawing to the real painting. That's 7 to 1. Do you see why it's backwards? So the answer here would actually be 5/3, right? Because we want to go from the drawing to the painting. So we need to go 5/3. To go from the drawing to the painting, see, to get from 9 to 15, we would have to multiply by 5/3. Look at it. You get 45 over 3, which is 15. See, 15. If we multiply 6 by 5/3, we'll get to 10. Okay, do you see how you actually compare them in the opposite way but get the scale factor? Yeah, I hope you guys got that. Okay, here we go, scale drawing. In the drawing, 3 centimeters represents 5 meters. Okay, so we have 3 cm to meters, 3 to 5. 3 represents 5. Okay, assume the dining hall is rectangular. Okay, find the area of the real dining hall. Real. All right. Well, what we need is, first of all, if it says find the area, you guys should know the formula for area. It's length times width of a rectangle. Okay. And we've got a 3 by 6, right? So if we know 3 centimeters represents 5 meters, right? There's a couple ways to do this. You could just set up a proportion, right? You could be like 6 over x centimeters, 6 centimeters, because this is 6, and we could find the length. Cross multiply, you'll get 3x equals 30, or x is equal to 10. Okay. Some of you might be able to just divide this into 2 and be like, oh, here's 3, that's 5 meters. And here's another 3, that's 5 meters. Therefore, this side is 10 meters. This is 3 centimeters. 3 centimeters is 5 meters. So we have 5 times 10. Area is equal to 5 times, actually the length is, it doesn't matter, but just because I'm trying to be good. Okay, 50. And it's going to be centimeters squared because area is always squared because area is always talking about how many little squares do we have. Yeah. How many little squares do we have? That's what area is about. All right. Except that's going to bug me because I didn't do it in the correct way. So I'm just going to erase it. Okay. The correct way would have been to do this. 1, 2, 3. 3, right? Anyway, it's fine. You don't need to worry about that. That's not the end of these notes. Okay. I have a couple more two more well, the second one of this and then one more topic after this. Okay. Okay, here we go. Same thing. 13 centimeters, 13 centimeters, 8 centimeters, 12. Scale drawing. 4 centimeters equals 5 meters. Bedroom is rectangular. Find the area. Area of a rectangle, length times width. Okay. We've got 8 times 12. Oh, if you notice what I'm doing is I'm converting before I'm multiplying. That's because it's easier. There's a whole nother formula without doing that, but it's way more annoying. Okay. So I recommend you change it first. Okay. So 8 centimeters. If 4 centimeters equals 5 meters, then 8 centimeters is going to be 10 meters because there's two of them. If you want to, you could set up a proportion. 4 over 5 equals 8 over x, and you could figure it out. Okay. Or just know your division. 12 centimeters, there's 3 fours. 4 plus 4 plus 4, which means 5 times 3, 15 meters. So your area is going to be 10 times 15. Area is equal to 150 meters squared because area is always squared. Okay. Again, you could have also set a proportion. 4 over 5 is equal to 12 over x. It doesn't matter. It always works out. Okay. Next. Okay. This one says reproducing a scale drawing. So now you get to draw, which I think is fun. In the figure below is made with a scale of 1 unit equals 3 meters. Okay, so 1, this is 3. Get it? Each 1 unit is 3. So in other words, this would be 9 meters, right? Okay. It says draw the figure with a new scale of 1 unit equals 9 meters. Okay, and you can place it anywhere. All right, so now look, they're literally telling you that 1 unit is 3 meters, and now they're saying 1 unit is 9 meters. Well, we got to shrink this down. This is 9, okay, total of 9 meters, because it's 3 plus 3 plus 3. This is 3, 2, 3, 4, 5, 6, 7, 8, 9. This is 27 meters. Okay, well, if 9 meters equals 1, we're just going to have one little bar here. Whoa. Lock her down. Okay. We're going to go one little bar. Okay. And then 27 divided by 9 is 3. So look, if this is 9, it'll be 1. Okay, little dude. Let's put you back. Okay. We're going to go 1, 2, 3. So you guys will be able to do this on Alex, but that's the new scale model. You can tell it's 9 by 27 because each one of these is 9. Okay, next one. All right, 1 unit equals 2 meters, 1 unit equals 8. So first let's get the distance. 2, 4, 6, 8. This is 8. This is 2, 4, 6, 8, 10, 12, 14, 16. Well, if 1 unit equals 8, okay, in this case, then we're just going to have 1. And this is 16. That means there's only 2. It's like the littlest rectangle ever. All right, and that's it. That's all for notes.